Okay guys, so next chapter we're looking at here is chapter 10. As you can see, it is geometry. Chapter 10 is all geometry, and obviously this book kind of covers a lot of different topics, jumps around from one topic to the next that may or may not be related. So like all that finance stuff we just looked at, not exactly related to geometry. So anyhow, know how to identify basic geometric shapes by name and how to calculate their measurements. So we're talking about planes, right? A flat surface with no thickness, no boundaries. A line segment, a portion of a line from one endpoint to another. So here you have two different ways you can name segment A, the same segment. You could call it segment AB or segment BA. You're basically naming it based on the endpoints. So on one end it would have point A, on the other end it would have point B, and you could call it either segment AB or segment BA. A ray is a portion of a line from one endpoint. So it goes, a line in like geometric theory, a line goes forever in both directions. So the segment stops, right? Segment has endpoints, the line goes forever. And a ray, it has one endpoint and goes forever in the other direction, kind of like here is ray SR and ray ST, and together they make an angle. As you can see, the union of two rays with a common endpoint is an angle. So the common endpoint is S, and then two rays, the union, right? The union of two rays with a common endpoint. Ray SR and ray ST form an angle RST. The vertex is the common endpoint of the two rays in an angle, so the vertex here is S. And then you can name an angle quite a few different ways, as long as there's no adjacent angles, no other angles with the same vertex. So there's no other angles with the same vertex here, so I could call this angle by the name angle S. I can kind of do a little connect the dots and outline the angle and call it angle RST. I can outline it in reverse order and call it angle TSR. And if an angle has a number as a name, we can name it angle 1. That would be different than the number of degrees. If it said like 50 degrees here, then I couldn't name the angle 50 degrees. That would be the measurement, okay? However, this one here is not a measurement. This one here is simply showing you that you can call it angle number 1, as identified here. And then we have example 1 right here. So let's go ahead and have a look at it. It says the hour hand of a clock moves from 12 to 2 o'clock. Through how many degrees does it move? There are 360 degrees in a complete circle. So 360 degrees divided by 12 means there's, again, complete circle, 360 degrees, aka a clock is a complete circle. There's 12 hours in a clock. So if you take 360 and divide by 12, you'd basically come to this conclusion that there's 30 degrees of movement between each hour. Between 1 and 2, 30 degrees. Between 2 and 3, 30 degrees, and so on. So from 12 to 2, the hand moves 2 hours, so it moves 60 degrees. 2 hours moved times 30 degrees per hour will give me 60 degrees. And now that I know each hour is 30 degrees, I could use that for this. The hour hand of a clock moves from 12 to 1 o'clock. It only moved 1 hour, so it only moved 30 degrees. So I can kind of try to sketch that, right? If you had a clock, right, and let's just say this is the minute hand and this is the hour hand, right? That's 12, right? It's the minute hand's pointing at 12. The hour hand here is pointing at 3. So, 12, let's just say 1, 2, and it has 12 total hours, right? And it is a circle at 360 degrees. So as this minute hand, or either one, as it moves from 1 hour to the next, it's moving 30 degrees. So if this little, as an hour passes, this hand is going to go from pointing at 3 to, pointing at 4. And then this amount of rotation we're saying is 30 degrees. So if it moves 1 hour, 30 degrees. If it moves 3 hours, it's 30, 60, 90 degrees, right? So that's kind of the concept here. Right here we just have our angle classification. You can classify an angle based on its measurement, right? That's not the same as naming an angle. Up top, we were naming an angle, and then this one's classifying an angle. So here's how you classify, and you guys might know this, right? An acute angle is an angle that's less than 90 degrees. A right angle is exactly 90 degrees. An obtuse angle is greater than 90 degrees. A straight angle is 180 degrees. And then these are not necessarily angle classifications. These are special pairs of angles, okay? If two angles are complementary, it means that they add up to 90 degrees. So maybe one angle's 40 degrees and one's 50. 40 plus 50 is 90. That would make them complementary. Or maybe one angle's, 35 and another one's 55. Complementary because it adds up to 90. Supplementary angles, two angles that add up to 180. So a student taught me once that 90 comes before 180, and if I'm counting, just regular counting, 90 comes before 180. And C comes before S in the alphabet. So they said, well, you can use that thought to remember complementary goes with 90 and supplementary goes with 180. Again, C comes before S and 90 comes before 180. So anyhow, supplementary angles, two angles that have a sum of 80, maybe one of them's 100 degrees and one of them's 80 degrees, or, any two angles, if their total sum is 180, they're supplementary. And then here we're supposed to use these sketches to figure out some angle measures. Find the measure of angle DBC. Let's see here, the measure of angle DBC. I don't really need to sketch anything because it's already sketched out, but I can see I have a 90 degree angle here, you guys. And I can see angle DBC is this piece of the 90 degree angle. And I can see this other angle. So this other angle here, ABD, right? You kind of have to, you got to get the vertex in the middle. I didn't mention that earlier, but when you name an angle using 3 letters, the vertex has to be the middle letter. Angle ABD is 62. As I mentioned, this one's unknown. And, but I do know this. I know that 62 plus this amount has to be 90 because I see these two angles, right? ABD and DBC form 90 degree angle, and I know it's 90 because it has this little box in the corner. So I'm going to write some stuff out here. Again, remember this is, let's see, so this in here, I'm just going to call this, whoops, okay, that's not quite, I wanted to call it X. So I was just calling this X because I don't know what it is. Angle CBD or DBC if you prefer. So I could take the, let's try a little bit of text here. Normally doing this freehand would be better. I could take the measure of angle ABD, and that's 62. And add the measure of angle DBC, which I don't know. So see what I'm writing here? That just means measure of angle. That's what you say. So the measure of the angle ABD plus the measure of angle DBC. That is going to be 90. But if I'm just using angle names, it's going to be the measure of angle ABC. Adding those two smaller angles to get that bigger angle. That's what I get. Remember, ABD is 62. DBC is unknown, it's X, and it equals the measure of angle ABC, which I know is 90 because it has that little box. So you can use this, two angles, two adjacent angles will add up to form the measurement of the, or two adjacent angle measures you can add to get the measurement of the larger angle they form. So anyhow, all you have to do here is now subtract 62 like you were solving an equation. And 90 minus 62, right, would give me that X equals 28 degrees. Okay, so that's the answer to that one. And then moving forward here, let's look at this one. The measure of angle ABD is 66 degrees greater than the measure of angle DBC. Find both angle measures. So kind of a lot going on in this one. Let me see here. So here's what I can do. If the measure, first of all, this is a straight line. So I need to know that just by seeing a straight line, I need to know it's 180 degrees, okay? So the straight line's 180 degrees, and then now that I have that, I can go ahead and move forward with this here. Let's see, so ABD is 66 greater than DBC, so ABD, this one's 66 greater than DBC. So I'm going to call this one X. Again, and then ABD is 66 greater than X, or greater than DBC. So I can call it, now that I have some, and I have some information that I can relate these. So if this one's 66 greater, well, I can call it X plus 66, okay? And so since I have some information regarding these angles, I can do that. Again, this one's X and this one's 66 greater, so X plus 66. And then the last thing is this. Got to put quite a few different little thoughts together here. If they form a straight angle, they add up to 180. Again, if they form a straight angle or a line, a straight angle is simply a line, then they add up to 180. So CBA is a straight line. So that means these two angles have to add up to 180. So I can write that out also. X plus 66. And remember the reason that I can add these up and equal them to 180 is because they form a straight line. So solving this, guys, if you were to solve this right, you'd get, let me move to the text option actually.
What was that, Daddy?
So if you guys carry on and solve this equation, subtract 166 on, or wait a second, sorry, it's just 66, not 166. Subtract 66 on both sides, you'll get 2x equals, right, 180 minus 66 is 114, and then here, divide both sides by 2, right, and you will get x equals, what is that, 57, right? And then you'll get your two angles. The measure of angle ABD is x plus 66, so 57 plus 66 is that 123, and 123 degrees. Remember, angles are measured in degrees. And the other one, the measure of angle DBC, or CBD if you prefer, equals 57, as we calculated x is 57. So there's that. Alright, so I'm going to carry on, guys. I just did this problem here, B. I'm going to just carry on paper because writing with the electronic tools is just too much of a pain. So anyhow, let's see. Measure angle ABD is 88 greater than DBC. This is exactly like the last one. So I have practice 2-3. Right, that's what I'm on here. Practice 2-3, and the problem is, well, it can be sketched out. It doesn't need to be. It's already sketched out in the notes, but I'll go ahead and show that. C, D, A, and I've got D here, and let's see. ABD is 88 greater than DBC. ABD is 88 greater than DBC, so I can again call DBC X, and ABD is 88 greater than that, so 88 greater than X is X plus 88. Together they form a straight line. Together these angles form a straight line, so that means I can, add their measurements, X plus 88, and it equals 180, because two angles that form a straight line are always going to add up to 180. It's called a linear pair. They're also supplementary angles if you want to go there, but again, two angles that form a line, it's a linear pair, and linear pairs are always supplementary, meaning they always add up to 180. So 2x plus 88 equals 180, subtract 88 and get 2x equals, what is that going to be, 92. So x is 46 on this one, and then once we have x is 46, the measure of each angle, well, this one's 46, right? And then this one is 46 plus 88, so what is that, 134? And then you can kind of do your last little mental math. 134 plus 46 is 180, as it should be. So moving along here, guys, let's see. The next problem, it's vertical angles. Vertical angles are always formed by two intersecting lines. Okay, so you guys have this sketch here with two intersecting lines. It has angles 1, 2, 3, and this one is 68. And the deal here is that vertical angles are always congruent, okay? This is example 4, by the way. Vertical angles are congruent. And moving forward, sorry it's so sloppy, guys. It's congruent, congruent. And anyhow, we're going to use a symbol for that, okay? The symbol for congruent is that. And basically vertical angles are either on top and bottom of each other or left and right. And they're always equal. So angles 2 and 3 are equal. Angles 1 and this one that's 68 degrees are equal. So the measure angle 1 is 68 degrees. And then the other two, right? Once I know this is 68, this one is not 168, it's 68. But either way, we have a straight line. So that means 180 minus 68 will give me the measure of angle 2, so 112. And if angle 2 is 112, so is angle 3, because those are also vertical angles. So that was, again, angle 1 is vertical with 68, so angle 1 is 68 degrees, and then since they form a straight line here, 180 minus 68 gives me 112, measure of angle 2 is 112, and then I don't need to calculate for 3 because if it's vertical angle with 3, it's equal, so it's 112. It says use the figure above, assume the angle on the left measures 57, find the other 3 angles. So in practice 4, let's see here. It says use the same angles, and it says assume the angle on the left is 57 degrees, and we still have angles 1, 2, and 3. Well, angle 1 has to be 57. These are vertical. Vertical angles are always congruent, so the measure of angle 1 is definitely 57. If I take 180 minus 57, I can get these other angles because, 57 degrees forms a straight line with angle 2. So this has to be 180. So 180 minus 57 will leave me with the measure of angle 2. So 180 minus 57, what is that, 123? Angle 2 is 123 degrees. Again, I know that because I have a linear pair here. This angle and this angle form a straight line. And you can use any angles that form a straight line to do this. And then since angle 2 is 123, so is angle 3 because they are vertical angles. Vertical angles are always formed by two intersecting lines, two lines that cross. The angles on top and bottom are vertical, they're equal. The angles on the right and left are equal to each other. Those are vertical, so that. And I believe that is the end of these notes. Yes, it is. So thanks for having a look, and use it to do the assigned problems.